In this video, you will learn how to apply the difference of two squares factorization to factorize algebraic expressions such as 16 minus x squared, 4x squared minus 25, 2x squared minus 8, and x squared minus 5. Last time, you learned how to factorize common factors from algebraic expressions. If you haven't watched the video yet, the link will be in the description down below. What is a perfect square? In maths, we are often faced with problems that involve the product of two equal integers. For example, a garden may have equal dimensions of, say, x meters. The area of the garden can be obtained using the formula area is equal to side times side. In this case, x meters times x meters, which is x squared meter squared. We say that the garden is a square. Hence, a perfect square is a number obtained by squaring a whole number. For example, 16 is a perfect square because it is obtained by squaring the number 4. Let's consider the expansion a plus b into a minus b. Using 4, we obtain a squared minus ab plus ab minus b squared, which is a squared minus b squared. Thus, factorizing a squared minus b squared gives a plus b into a minus b. A squared minus b squared is called the difference of two squares. Let's demonstrate with the following examples. Fully factorize 16 minus x squared. Notice that 16 and x squared are perfect squares. So we are finding the difference of two perfect squares. We can rewrite 16 minus x squared as 4 squared minus x squared. Applying the difference of two squares formula, we get 4 plus x into 4 minus x. 2. 4x squared minus 25. Here, 4x squared is a perfect square and can be written as 2x all that squared. 25 too is a perfect squared and written as 5 squared. So 4x squared minus 25 becomes 2x all that squared minus 5 squared. Applying the difference of two squares formula, we obtain 2x plus 5 into 2x minus 5. Next, negative 2x squared plus 8. It will be much easier if we reorder the expression, writing it as 8 minus 2x squared. This is a good habit to conceive in maths to ensure you don't mess up with signs which may eventually cost you marks. Are you familiar with this expression? I knew you are. 2 can divide both terms, so let's factor out 2. And we obtain 2 into 4 minus x squared. The expression in bracket is the difference of two squares and is written 2 squared minus x squared. Finally, applying the formula once more, we get 2 into 2 plus x into 2 minus x. What about x squared minus 5? I know what you are thinking. Even though 5 is not a perfect square, it can be written as root 5 squared. Therefore, x squared minus 5 becomes x squared minus root 5 squared. Applying the difference of two squares, we get x plus root 5 into x minus root 5. Top tips. Always verify your factors by multiplying out the brackets, making sure you arrive at the given expression. Root a squared is equal to a. That is, square is the inverse of square root. The sum of two squares does not factorize into two linear roots. That is to say, a squared plus b squared is not equal to a plus b into a plus b. Exercise. Try the following using the difference of two squares factorization to factorize the following. You may want to pause the video and return when you are through. Working correctly produce the following results. Next, we will be looking at how to factorize quadratic trinomials of the form ax squared plus bx plus c Thanks for watching and stay tuned.